Welcome to part 3 of Competency 7. In this video, we will work with derivatives and integrals. Okay, before we begin, let's discuss derivatives and integrals. No, you will not directly teach these, but it is your job to understand them and know the foundational things, elements, and fundamentals that all students need to know before they can move on to calculus. So in middle school, we do teach algebra in 8th grade, and the expectation is that you know and understand these things. Okay. All right. So before we begin, it says use the graph of the curve below to answer the following questions. Each line is said to be tangent to the given curve. Okay. Now, in the intro of this video, you saw where it said the change of a line at a point. That's what we're being asked about. Well, the line must be tangent, or rather, the fact that they said it's tangent, this is telling me that this is an instantaneous rate of change, which is very much a calculus element. Okay. All right. So let's look at number 1, and we'll just move up a tad bit, but we still need to see our picture. Okay. What is the change of y over the change of x of the line at point A? Well, that's the same formula that we did in the prior video. That's just the slope of the tangent line. So how do we calculate this? Well, we can't use that formula. Well, you put it in y-intercept form and voila, and we have it. So A is the purple. Okay, so what I'm going to do is let's take this pen and actually change it to purple. Okay, and then I'll come up here. All right, so we have 5.22 y equals 24.6. Okay, this will be plus 2x. Okay, now when you go through the process to divide everything by the coefficient of 5.22, and we have to do it to each term. Okay, when you do that, you actually get what we need for our slope. Okay, regardless of what these end up being, I'm not even going to calculate them. This is what we're looking for right here. Okay, I'm going to put it back in purple. So m equals, we'll put it in your calculator. Here's your fraction. 2 over, go down, 5.22, enter. And it is roughly, okay, so I need to get rid of this. This needs to be an estimation, as my daughter says. I love a guesstimation, mommy. Okay, here you go. All right, you have 3/8. Okay, and this gives us option C. And as you see, A and B could be eliminated because they're trying to quote unquote fool you. We have to follow through our calculations in order to get what that slope is at that point, and that line is tangent. Okay, there we go. That gives us the change of y over the change of x. Okay, now, same thing with point C. Okay, so I'll move up, go to my pink. All right, so what do we have for this particular item? Well, now you could cut to the chase and see what it looks like, but I'm going to follow through. We have 3.18y equals 9.53. Now that will be minus 0.05x. Now, of course, now we divide every term by the coefficient in front of the y to get rid of it, which gives us, okay, this, let me put a circle around it. This particular situation, well, that's where we pull out the fraction that we need. Okay, that's the part that we need to get our slope. So m equals, okay, and remember, we're doing C, doing this one, the pink. Okay, so let me see here. It looks like we're going to be estimating again. Well, if you look at it, we have two decimals in that fraction. Okay, and I can tell you right now, we have a negative. So let's go down here to 2, and we get rid of A because it's positive, and C because it's positive. Now we have 2 left. Oh, I think D's not it. That is way too large a number. But don't be fooled. Sometimes decimals do give you large numbers. So at least we know it's negative. So let's set up our fraction. All right. We have 0.05. Oops. Let's go out in front and put our negative. There we go. Now let's go back. Let's capture that denominator or enter it 3.18. Enter. And there you go. We didn't even have to push toggle because there is no equivalency because it's just this wild decimal. Okay. Now, as an estimation, I'm seeing negative 0.0, and we can round to 2. So therefore, B is verified, and yes, D is way too large. Okay, great. So let's move on to number 3. Use the figure below to answer the question that follows. Okay, number 3. Which of the following calculus topics could be demonstrated by finding the area of the trapezoid above? Okay, let's take a look at this and think about some of the things we've done in the other videos, okay? And our basic knowledge of calculus, okay? So A says the derivative of a function at a point. No, I don't see a curve, I don't see a tangent line, and I don't think area has anything to do with instantaneous rate of change or even rate of change. Okay, so let's mark out A. That I don't think is going to work there. Let's look at B. The limit of a function as of x as x goes to infinity. No. And none of this applies, okay? The line going to infinity, this line is unbounded. And you're creating an area with an interval, okay? And that screams something else to me. And you should know it the minute we get this interval, okay? All right, so let's mark this out. And let's look and see. The definite integral. Mm, that's what should be screaming at you. Because of this and this, we should want to write this. Okay. We have this interval from 1 to 4, and that gives us something to measure. Okay. And then we have something that we can integrate, which is 1/4 x plus 2 dx. Now, our calculator doesn't do this for us, but we don't want to do this right now. Okay. And yes, in middle school, you don't teach this, but you do need to have an understanding of these elements because these are the foundations of this are important topics in eighth grade mathematics. You'll see a little bit coming on there for the students, especially, some rate of change and things like that. And then also your eighth grade algebra students, okay? They need that good foundation to move on to the next things in high school. Okay, so as an educator taking this certification test, you need to know this, and it is in this competency. If it's in the competency and you're an educator and you should always know what's next, so it's fair game. They can ask you some pre-cal questions, definitely. So C is what we need, okay? And that would be the formula that you would use if you wanted to find it. Of course, that's not what we would do at the middle school level. In the middle school level, what we would do is have the kids like find a way to estimate it. Like, here's a triangle, we could find that, and here's a rectangle, And this is what we would put together, which should it's a composition, remember, you should be very familiar with that. Anyway, let's look at D. Newton's method to find these zeros of a function. No. Wrong kind of function, wrong kind of image, wrong everything. So, sorry, Newton, you're out. Okay? All right, now let's move on to a different situation where this would apply. Okay? What is the estimated area under the curve y equals negative 2x squared minus 8x bounded by the x-axis? So they are bounding it here. Okay. And remember, we're using the absolute value. Okay. So that would be a total of a distance of 4. And over here on this edge, you have a distance of 8. Now, automatically, you should see something that you need to eliminate. 4 times 8 is 32. Obviously, 32 would be way too large. Okay, what you would be doing is creating this. Okay, this area would be too vast. So 32 would not work. Now, let's think of an area that we could calculate that would be too small. Okay? What if we right here created a triangle in the middle of that rectangle? Okay? This little bit here. Okay? Well, that would be 32 divided by 2. Well, that's 16. That's not large enough. Here, and let me draw the picture a little bit better here. We would be looking at this right here. Okay, so this tells me all of this in here, that's too small. It's not great enough. So that's A. Get rid of it. Now let's look at C. 16.5. Is that little edge, that little bit right here, would that be half a unit? Because remember, we're talking in units. No, I think that's bigger than half a unit. Well, let me get rid of all of this business I've got going on right here. Okay? And let me show you a way that we can quickly just say, I'm thinking it's D. But I need to verify that, validate that some way. Well, if you look here, I'm going to do this. Okay? Now, with this little section right here, okay? This little section, yes, it will be underestimated, but I have two of those. I have one on one side, one on the other. Okay? Right. And that's 1 times 6. 1 times 6 divided by 2. That's a little triangle that equals 3. And I have two of those. Okay? All right. So that's 3 plus 3. Now, let's look at this. Let me go ahead and draw this here. That means that here I have 2 by 6. I have the entire rectangle. Well, 2 times 6 is 12. So I can add that area of 12. Now I can go up here, move this up. Now in this little zone, I could create a triangle here. Well, how do I get that little piece of an area? Well, that is 2 times 1. 2 times 1 is 2. Divide that by 2. Well, add another 1 onto that. Now let's add all that up and see what I get. 3 plus 3 plus the 12 plus 1 more, that's 19. So that is a great estimate. It does equal 19, but I'm going to say that, here, let me get rid of that. I'm going to say we are roughly 19 units, and it did say estimate the area. Therefore, I know, and obviously it's logical that 16.5 was not. It's too lean an estimate. It just isn't going to work. Okay. Now, if you go to calculate this, you grab your TI 84, you can go ahead and put in, and you can use the -4. I did it and it works great. -4 to 0. And then use what they have here. They gave the curve to you, -2x squared minus 8x dx. And just pop that in and you'll get an answer. And it actually is equal to 21.3 repeating. So just saying, that's a good little estimate to work with. And that will be something when you're, and as I said before, you're working with composite figures when the students do that. And that's why we teach composite figures. Oh, and FYI, a lot of students are really poor at composite figures. It just baffles them at first. But anyway, you can get them through it. All right, this is the last question in this video. Happy testing, everybody. And thank you for liking us, sharing us, and subscribing. Good luck, everybody.